Hello, my name is Abdullah Özüm Düzgün and this is my EE102 term project. I want to design a voice-to-text converter. This idea came to my mind while we are talking with my friends, and iPhone has Siri interface for voice-to-text conversion, and Google has its own. So this is a very basic voice-to-text converter, and it is not yet artificial. In the future, I hope it will become artificial. So my voice text converter uses digital PMOD 3 for voice inputs, and I am using a Basis 3 board for my VHDL programming. And I want to demonstrate my outputs on the monitor by using a VGA code. So microphone is working based on an SPI interface diagram, SPI interface code. So let me show you the analog digital converters timing diagram. As it's shown in this figure, there is 16 clock cycles for outputs, for inputs to be detected by the microphone. After this 16 clock cycle, the data is transmitted to the board. So I had to create a SPI clock by using Basis 3's clock by creating a clock divider. You can create a clock divider in the range of 20 Hz to 20 megahertz. So I used the 1 megahertz clock for this project. So let me show you the final state machine for this project. We have three states for voice input and demonstration. In the idle state, chip select is 1. So transmission begins with the start signal 1, and I am controlling this start signal by the switch from the Basis 3, this switch V17. So when the switch is on, state is shifted to the shift state. This shift state where the microphone detects the input voice signal from the user, and then when it is automatically goes to sync data state when the shift counter is 15. So how this shift counter works, let me show you. In each clock cycle, shift counter is incremented by 1, so which equals to 16, which means that shifting data is done. Then the conversion will transmit to my local variable data. So let me show you how this device works. We are giving the voice inputs by opening this switch, and then when we close it and then reopen it, the output data will be demonstrated on the screen. So I had to give my voice input by opening the switch and reopen it. I can see the output data. Let me show you some demonstrations.
A, B, C.
So in this conversion, PMOD MIG 3 does not convert based on the frequency level of the voice input, but it transfers the analog value to digital value by considering its decibel value. So I sampled data before this demo, and according to these sample data, I checked which bits are repeating many times for each character. So then I wrote a code based on these repeating indexes of 12-bit data. In these sampling data, I saw same values for character A, B, and C, which corresponds with the conversion idea behind the PMOD MIG 3. Since this transfer is based on decibel level of the voice input, for example, A and B and C can have same decibel value, but I solved this problem by analyzing these sample data and checked the repetition. Then I wrote this code. So this is all about my project. Thank you for listening to me.